A map was drawn in October 1985. One town was marked in red. Beside it, a printed number, 100%. 10 copies were made. 37 days later, a wall of mud and rock came down the river valley at 30 miles an hour and took that town off the map in less than half an hour. 23,000 people. The map still exists. The town was called Armero. 29,000 residents, a flat green plain in central Colombia. 30 miles east, a volcano with a glacier on its summit. The report attached to the map named Armero first among the towns at risk. The phrase it used was 100% probability of mudflows. Date on the report? The 7th of October. A simplified version ran in color on the front page of a Bogotá newspaper. Copies of the technical version? About 10. The governor of the province containing Armero did not attend the meeting where it was handed over. 9:08 in the evening, the 13th of November, the volcano erupted for roughly 20 minutes. On the scale volcanologists use, that eruption rates a 3 out of 8. I have read what came with that map. There is not one hedged sentence in it. The mountain drains into 3 rivers. Every one of them had towns along it. On the night of the 13th of November, mud went down all 3. A town on the western slope lost roughly 1,800 people in the same hours. 13 villages beyond Armero were destroyed. Different valleys, different towns, one mechanism. 23,000 dead makes this the second deadliest volcanic disaster of the 20th century. Only Mont Pelée in 1902 killed more. Pelée annihilated St. Pierre with a pyroclastic surge, a mountain doing the most violent thing a mountain is capable of. Nevado del Ruiz did almost nothing at all. A revised version of the hazard map was scheduled for public presentation on the 12th of November. The presentation was moved to the 15th. A meeting of the mayors of the threatened towns was set for the 15th as well. Armero was destroyed on the 13th. Here is the account that has been offered ever since. Nobody could have known the date, that is true. Volcanology in 1985 could not name a day, and it cannot name a day now. But the map was never a prediction of when, it was a prediction of where. It named the valleys the mud would use, the towns those valleys ran through, and the order in which they would be reached. Every one of those predictions came true inside 5 weeks. Where is what killed them, and where was already on paper. So the question is not whether the warning existed. The warning sits in an archive, dated, signed, printed in a newspaper. The question is why a national hazard assessment for a country of 30 million circulated in roughly 10 copies. Who holds the authority to look at a printed 100% and decide it does not justify emptying a street? What a forecast is worth when no institution is legally required to act on one. And how many towns are asleep tonight inside a red line on a map that nobody with power has read? By the end of this, it will be clear why the 2 seismologists who could have read the instruments that week never boarded their plane, and what happened in Bogotá 6 days earlier that kept them on the ground. One more thing about Armero before the mountain wakes up. The plain the town stood on was flat, and it was fertile, and both of those things had a cause. In 1845, mud from the same volcano came down this same river and buried the same valley, killing more than 1,000 people. It left behind a level, rich sheet of sediment. 2.5 centuries earlier, in 1595, an earlier flow down these rivers killed 636.
Armero was built afterward, on top of the deposit. The good soil was the last disaster. The town was standing on the evidence, and it did not look like a place at risk. Armero in 1985 was no village clinging to a slope. It was a working agricultural town on the Tolima Plain. Rice, cotton, a hospital, a hotel, businesses, bus routes. Nothing about it looked precarious. Everything about the ground under it was. Locals called the mountain the Sleeping Lion. It had done nothing serious in 69 years, which means the eruption is not the answer to this. Something else did it. In December 1984, 3 significant earthquakes were recorded within 20 miles of the summit. Colombia at that point had several active volcanoes, no volcano observatory, and no scientists trained as specialists in volcanology. The mountain had been quiet through the entire working life of everyone who lived beneath it. The earthquakes were noted.
Nothing was built to watch them. In January, geologists climbed to the top to look. What they found inside the summit crater was a second crater, a fresh vent that had opened inside the old one. They came down and reported that the volcano needed to be monitored. To stand where they stood, you have to climb above 17,000 feet. The air holds roughly half the oxygen of sea level. Fumaroles vent sulfur that burns the back of the throat through a wet cloth. And underfoot, in the tropics, 4 degrees north of the equator, there is ice, a glacier cap several square miles across, sitting directly on top of an active magma system. That ice is the entire story. Nothing else about this mountain matters as much. Among the Colombian geologists working the volcano through that year was Marta Lucia Calvache, who would spend the following decades of her career on this problem and eventually run the country's geological service.
In the month before the eruption, she and her colleagues put their conclusions in writing and submitted them. The geological history of the mountain and the likelihood of an eruption within months or years. Through February and March, the fumaroles strengthened and earthquakes were felt in the towns. In April, a United Nations agency assembled an expert team in anticipation of being asked for one. The request did not come. Instruments to measure the mountain did not reach it until mid-summer, 6 months after the geologists came down from the crater and said they were needed. And none of this was new information about this particular volcano. In 1850, the Colombian scholar Joaquín Acosta published an account of the mountains of Ruiz and Tolima and the muddy eruptions of the Magdalena in a French geological bulletin. He was describing the 1845 flow, 5 years after it happened, in a scientific journal in Europe.
The mechanism of this mountain was not obscure local memory. It was in the international literature 135 years before Armero was destroyed, published by a Colombian. Now the physics, because it explains a number that otherwise makes no sense. On the Volcanic Explosivity Index, the eruption of the 13th of November 1985 rates a 3. Mount St. Helens 5 years earlier rated a 5 and ejected something on the order of 30 times more material. Mount St. Helens killed 57 people. Nevado del Ruiz killed 23,000. The difference is not power, it is the glacier. A volcano with no ice on it throws rock and ash, and the damage stays broadly local. A volcano with ice on it does something else entirely. Hot debris spreads across the ice cap at several hundred degrees and converts snow and ice to water in minutes. That water does not sit on a slope. It runs, and it runs into channels already packed with the loose rubble of every previous eruption, and it picks that rubble up as it goes. What arrives at the bottom is a lahar, not a flood and not a landslide, a moving slurry of water, ash, sand, boulders, and shattered trees with the consistency of setting concrete, running down a river channel under gravity, gaining mass the whole way. Only about 1/10 of the ice cap melted that night. 1/10 was enough. There is one further property of a lahar that matters more than any other, and it is why a hazard map for this mountain has to be drawn in corridors instead of circles. Ash falls in a rough circle, and a circle has an edge. A lahar does not spread outward. It follows a river, and a river can run for 50 miles. 30 miles out, Armero was far outside anything a reasonable person would call the slope of a volcano. It was well inside the channel of one.
And on the 11th of September, 2 months before the catastrophe, the mountain ran the entire sequence in miniature. A small steam explosion at the summit put a small mudflow down one river. Nobody was hurt. It behaved exactly the way the physics said it would. That was the demonstration. It had one effect, and it was the right one. The government finally moved. What the government produced was the map. There are 2 histories of 1985 on this mountain. One has just been told: seismographs, fumaroles, a glacier, a crater inside a crater. The other happened in offices, and it is the one that has since been reconstructed in forensic detail, most thoroughly in a 1990 retrospective by the volcanologist Barry Voigt, whose work is the reason so much of what follows can be stated to the day. In May, a visiting United Nations disaster relief scientist made 3 recommendations. Produce a hazard map. Build a civil defense plan around it. Install monitoring on the volcano. Every item was correct, and every item was eventually done, in the wrong order and too slowly. In June, the United States Geological Survey shipped equipment but declined to send a specialist. In the same period, a United Nations scientific agency formally offered Colombia a full expert team with instruments. The offer arrived as a letter addressed to a government ministry. Inside that ministry, the letter was lost, and it stayed lost for 2 months. By July, the provincial authorities on the western side of the mountain had stopped waiting for the capital. They formed their own risk committee and requested foreign assistance directly. Then came the 11th of September, the small eruption and the small mudflow. Within 3 weeks, a hazard map existed. Geologists from the National Geological Institute, a regional power utility, and a local university built it together and delivered it with a report on the 7th of October. The map worked. That is the fact to hold on to. It marked the 3 river corridors. It named the towns inside them. It gave the mudflow probability for the Armero corridor as 100%. The accompanying analysis stated that mudflows and floods were effectively inevitable, and that Armero itself could be evacuated in 2 hours without danger. 2 hours. Written down 5 weeks in advance by people who had measured the distance. The effort that followed was real, and it was concentrated in the wrong place. Through mid-October, the Geological Institute supplied technical advice to organizations on the western side of the mountain, where lectures and public forums on volcanic risk were held. Manizales, the largest city near the volcano, was close, alert, and organizing. Armero sat farther away, on the far side of the summit, in a different province, and the governor of that province was not in the room when the map was handed over. Then, the distribution. A generalized version appeared in color on the front page of the Bogotá daily El Espectador, with the map symbols reproduced incorrectly so that the version the public saw was harder to read than the one the geologists drew. The technical version went to a small number of national officials, a provincial governor, and civil defense, about 10 copies in total for river corridors holding tens of thousands of people. The recorded objections were not scientific. The concerns raised were about panic and about what a published hazard zone would do to property values. In the national legislature, the scientists were accused of alarmism. I want to be exact about this because it is the hinge of the entire story. The map was not suppressed. It was not classified, buried, or denied. It was received, read, weighed against property prices, printed wrong in a newspaper, and filed. And the objection about panic deserves a straight answer because it recurs in every case of this kind.
Emptying a town of 29,000 people for a volcano that might not erupt for years carries real costs. Lost harvests, lost wages, and lost credibility for the next warning. Those costs can be estimated in advance. The alternative cost cannot until it arrives. On the 21st of October, ground deformation measurement finally began on the volcano. Too late to establish a baseline, and therefore too late to detect the change it existed to detect. In the first days of November, with the mountain in active unrest, the operating cost of the seismic network was under discussion, and so was the option of removing it. On the 10th of November, 3 days of volcanic tremor began. On the 12th of November, the revised hazard map was to be presented publicly. It was postponed to the 15th. On the 13th of November, at 6 minutes past 3 in the afternoon, the mountain began to erupt. The afternoon eruption was steam and ash. It put a gray column over the summit and dropped grit on the towns below, and in clear air, it was visible for miles. The timing was almost impossibly favorable. A regional emergency committee for the province containing Armero was in session that same afternoon, at a planning meeting scheduled long in advance. It issued preliminary warnings. Then the ash stopped falling, the mountain went quiet again,
Conditions were assessed as normal, and the warnings were stood down. By early evening, a storm had moved over the region. Rain washed the ash out of the air and out of the streets. On local radio, residents were told to stay calm and remain in their homes. The mayor and the parish priest gave the same assurance. There was no danger tonight. In the reconstruction of that evening, there is no trace of malice anywhere in it. There is only the ordinary, reasonable conclusion that the emergency had passed.
Accounts of the evening also include a call for evacuation, raised by local relief workers while the ash was still falling, and withdrawn once it stopped. That detail is reported rather than documented to the standard of the rest of this record. If it is accurate, then Armero was told to leave and then told to go home a few hours before the mud. The September eruption had done something else, quietly, that nobody accounted for. It had been a warning that came to nothing. 2 months of alerts followed by an afternoon of harmless grit teaches a population exactly one lesson, and it is the wrong one. Investigators of this disaster list the refusal to accept a false alarm among its direct causes. At 8 minutes past 9, the mountain erupted properly. This was the magmatic eruption, the one the seismographs had been describing for 11 months. Hot pyroclastic material spread out across the summit ice in every direction. The eruption lasted about 20 minutes.
Roughly a tenth of the ice cap converted to water inside that window, and the water went into the channels. Nobody in Armero saw it. Nobody in Armero heard it. The mountain was 30 miles away, inside a rainstorm, at night, behind cloud. In the town, rain was falling hard enough on metal roofing to cover any sound from upstream. The single most important event in the history of that valley occurred in complete sensory silence to an audience of 29,000 people who had been advised to stay indoors. And here is the margin. The mud needed roughly 2 hours and 20 minutes to cover the distance from the ice cap to the streets of Armero. The report from the 7th of October had estimated the town could be cleared in 2 hours. The margin existed. It matched the estimate. It was never used because using it required a chain that had never been built. Someone at the volcano who understood what the tremor meant, a line from that person to an authority with the power to act, and a line from that authority to the town. Every link in that chain was missing, off-duty, or occupied elsewhere. The eruption itself was not a secret. It was recorded on the seismic network as it happened, by instruments installed too late for everything else, but working perfectly for this. The information existed inside Colombia that night, in the hands of people who understood precisely what it meant. It never reached Armero in a form anyone acted on. The distance the mud covered in 2 hours and 20 minutes, the warning did not cover at all. For those 2 hours, the flow was in the gorges, and it was growing. It scoured its own channel bed, stripped material off the valley walls, lifted the sediment of the 1845 deposit back out of the ground, and multiplied. The volume that reached the plain was several times the volume of meltwater that had left the ice. At about 11:30 at night, the flow came out of the mountains onto the flat ground where the river slows and spreads. There was no wave on a horizon and no view of anything at all. There was first a sound arriving from upstream that was not thunder and did not break and did not stop. By the time it stopped, the streets lay under 7 to 16 feet of material with a density of wet concrete, and the street grid of Armero had ceased to exist as a place where anyone lived. 12 hours later, the first relief workers reached the edge of it and discovered that they could not walk on the surface. In the years afterward, the flow itself was studied more precisely than almost any comparable event of the 20th century. A team led by the United States Geological Survey geologist Thomas Pearson mapped the melting, the mobilization, and the deposits and published the reconstruction in 1990. A separate group, including the volcanologist Haraldur Sigurdsson, reached the site within days and published in the journal Science in 1986. Their subject was, by death toll, among the largest volcanic disasters in recorded human history. produced by an eruption too small to have made international news if it had happened on a mountain without ice. The reconstruction produced a result that ought to be better known than it is. The eruption did not send a weapon down the mountain, it sent water. The weapon was assembled in transit, out of the valley itself, by the water. The arithmetic runs like this. A modest eruption melts about 1/10 of an ice cap. The meltwater enters steep channels loaded with the debris of previous eruptions and entrains that debris as it descends. Solid fraction climbs, density climbs, and the flow stops behaving like water and starts behaving like moving concrete. Peak volume arrived on the plain several times larger than the volume that came off the ice. Speed on the upper slopes reached roughly 37 miles an hour. By the time the front entered the town, it had slowed to something nearer 13. 13 miles an hour is a running pace. It did not need to be faster because it arrived at 11:30 at night, in a rainstorm, at a town that had been told to stay indoors. And because what it carried could not be waded through, swum through, or pushed aside. The deposits recorded the shape of it. The flow came not as one front, but as a series of pulses, each lower and slower than the last. The first accounting for nearly all of the destruction, and the later ones settling on top. On the plain, the material lost its water and stiffened as it halted, which is why the surface set hard. A lahar deposit is not silt, it is a poured floor. The valley built the thing that destroyed Armero out of the remains of the last time it destroyed Armero. Now the other half of this, and the promise from the beginning. 1985 was not a quiet year in Colombia by any measure. The country was inside an armed internal conflict. The government had troops committed to it, and the attention of the state was a finite resource being spent elsewhere for most of the 11 months the mountains spent shaking. Foreign scientists who visited that year recorded a national administration for which the volcano was a secondary item on a crowded desk. Through the autumn, the Colombian scientists were reading an increasingly loud seismic record with limited instrumentation and no resident specialist who had ever worked a volcanic crisis before. 2 seismologists from the United States Geological Survey were scheduled to travel to Colombia in the days before the eruption to help interpret exactly that record. They never came. Their trip was canceled. On the 6th and 7th of November 1985, an armed group seized the Supreme Court building in central Bogotá. The army stormed it. Roughly 100 people were killed, among them sitting justices of the court. For the week that followed, the Colombian state had one crisis, and it was constitutional, and it was in the capital. 6 days later, 200 miles away, a mountain that had been signaling for 11 months finished what it had started. The 2 people best equipped to read the last of those signals were not in the country because of an event that had nothing to do with geology. I have been through this chronology more times than I can defend, looking for the single decision that would have changed the outcome. There isn't one. That is what makes it worth telling. There is no villain in this file. There is a map that was right, a margin that was accurate, a warning stood down for sound reasons, a storm at the worst possible hour, and a separate national catastrophe that took the last 2 experts off the plane. Every part of the system behaved reasonably. The system killed 23,000 people. Colombia reached that conclusion faster than anyone. At a mass funeral in the provincial capital, mourners raised a banner assigning the deaths not to the volcano, but to the government. That sentence became the country's verdict on itself, and it has never seriously been revised. The final accounting, about 23,000 dead, and some sources put it nearer 25,000. Roughly 5,000 injured, about 5,000 buildings destroyed, 13 villages besides Armero gone,
And more than 3,000 people never recovered, still listed as missing rather than dead because there was nothing left to recover them from. Armero was never rebuilt. The decision was taken not to try. The ground was consecrated and left as it stood, which means the town is still there. Foundations, street grid, cemetery wall, sealed under the deposit and growing over. It is one of the few places on Earth where the map of a town and the grave of a town are the same object. The survivors were resettled in towns nearby, and a new municipal center grew to absorb them. The site itself became a place people returned to on the 13th of November every year to stand on top of it. Armero was also struck off the administrative map. A municipality that had existed for well over a century stopped being a place with a population, and its name survives now only in compound form, attached to the neighboring town that took in what was left of it. There are very few disasters anywhere that erase a unit of local government. Then the country did something with it. In 1986, the United States Geological Survey and the American Development Agency established a permanent international volcano crisis response program. Its purpose was to put experienced volcanologists and portable instruments onto any dangerous volcano in the world within days of a request. It was created specifically because of this eruption. It exists because Armero never got one. In 1989, Colombia passed the first legal and institutional framework for disaster risk management in its history, a structure that named who is responsible, who decides, and who holds the authority to order people out. And then the mountain tested it. In June 1989, Nevado del Ruiz began doing precisely what it had done 4 years earlier. This time, there was a monitoring network on it, an observatory reading it, and daily bulletins going out. On the 30th of August, the observatory told the towns below that an eruption was imminent and that evacuation was necessary. The evacuation happened. Nobody died. The science had not improved in those 4 years. The physics of ice and hot rock was identical. The map of 1985 had been correct all along. The right corridors, the right towns, the right probability, 5 weeks early. What did not exist in 1985 and did exist in 1989 was an institution with the standing to say one word out loud and be obeyed. The difference between 23,000 and 0 was not knowledge, it was permission. That framework was rewritten and strengthened again in 2012. The country now runs a network of permanent volcano observatories, staffed continuously, publishing bulletins on mountains most of the world has never heard of. A 40-year assessment published in 2025 described the transformation in institutional terms rather than scientific ones. What changed in Colombia was the existence of institutions, the sharing of knowledge, and direct engagement with the communities living inside the corridors. The pattern has held. On another Colombian volcano in 2008, an eruption began at 9:45 at night. 4,000 residents were evacuated. A mudflow went through their town inside the hour. Nobody was killed. Marta Lucia Calvache, who had been working on Nevado del Ruiz in the months before the disaster, spent the rest of her career on that transformation, and her position on it is unambiguous. An eruption does not have to become a disaster. A volcanologist from the same service summarized the 1985 situation in one sentence. At the time, the country did not even have an institution responsible for volcanoes. Which leaves the uncomfortable half of the lesson. Nothing that failed in 1985 was scientific. Everything that failed was administrative. Administrative things can be built, which is the good news. They can also be quietly allowed to decay, which is not. Nevado del Ruiz is not extinct, and it has not gone quiet. The volcano has passed through repeated episodes of unrest in the decades since, and Colombia has raised its alert level and ordered residents out of the hazard corridor more than once on the strength of the same instruments that were absent in 1985. The corridor is still a corridor. The rivers still run where the map said they run. The instruments are the whole difference.
Seismometers, tilt meters, gas sensors, and cameras watch the summit continuously now, and the ice cap is measured rather than assumed. The glacier is smaller than it was in 1985, which lowers the maximum possible lahar, the only reassuring sentence in this story, and it arrives from a cause that should reassure nobody. What happened in that valley also traveled. Lahar detection systems now exist on glaciated volcanoes on several continents. The one in the Pacific Northwest of the United States is worth describing precisely because it is Armero's direct descendant. Acoustic sensors sit in the river valleys draining a heavily glaciated peak, listening for the ground vibration a lahar makes as it moves, wired to sirens in the towns downstream. Those towns are built on the flat, fertile deposits of previous lahars, exactly as Armero was, and tens of thousands of people live on them.
Workplaces and public buildings in the valley practice the walk to high ground on a schedule. The exposure is not a small problem. Hundreds of millions of people live within 60 miles of an active volcano, and the most dangerous of those volcanoes are the ones carrying permanent ice, because ice is what converts a modest eruption into something that can travel. Nevado del Ruiz has sent a destructive flow down these valleys 3 times in 4 centuries. The interval is not comforting. It is simply long enough that every generation gets to decide the question again from the beginning. And here is what 40 years with this file leaves behind. The forecast at Nevado del Ruiz was not a near miss. It was one of the most accurate hazard assessments ever produced in advance of the event it described. It named the mechanism, the corridors, the towns, the sequence, and the evacuation time 37 days early, and it was right about every one of them.
Judged as science, it is close to a perfect document. It did not save one person. Because between a correct document and an empty street, there is a final stretch of the chain with no instruments in it at all. It runs through a ministry where a letter can be misplaced for 2 months, an office where a hazard zone is weighed against property values, a legislature where scientists can be called alarmists, a radio station reading out a reassurance, a mayor with no protocol, and a telephone nobody thinks to lift because the ash has stopped falling and the evening looks calm. Seismometers cover the mountain. Nothing covers that stretch. It has never been instrumented anywhere on Earth. There is a specific reason that stretch resists instrumentation. Every other link in the chain measures something physical, and physical things can be calibrated against reality. The last link measures a judgment about other people, how much disruption they will tolerate, how much credibility a warning will spend, how the decision will look in the morning if the mountain does nothing at all. No sensor has ever been built for that, and the incentives inside it run the wrong way. Waiting is always the cheaper option on the day the choice is made. None of it requires assuming bad faith, and the story is worse without it. Every person in that chain behaved the way institutions reward people for behaving. They did not overreact. They waited for confirmation. They weighed a certain cost against an uncertain one, and they were careful with public money and public calm. The system did not fail because people ignored it. It failed while doing what it had been designed to do. What I keep returning to is not the eruption and not the mud. It is the 37 days. That is a longer warning than almost any catastrophe in the modern record has ever given anyone.
Every glaciated volcano with a town beneath it now has its map. The maps are drawn, printed, filed, and in most cases correct. So the question this valley leaves is not whether the next one will be forecast. It will be. The question is, how many of those maps have been read by someone with the authority to empty a street? And how many are simply in a drawer, accurate, and waiting for the 37 days to run out?